Welcome back. This is part 2 of chapter 1 of the O'Brien text for MIS311, picking up where we left off. Now this slide is all about a couple of things, but the most important part to me is the second half where it talks about the potential harm from IT or to IT. You're not quite sure how they mean it. But certainly when you look at the list and it says, golly, can IT be used to infringe upon your privacy? Gee, do you think? What if inaccurate information is out on the web about you? It's been known to happen. It's been known to be done deliberately. What if you're trying to get your credit score and there's stuff in there that's inaccurate about you? Can that hurt you? Oh, yeah. And collusion, inappropriate partnerships. Can that happen? Yes, and IT can certainly make those things happen easily enough. One of the efforts that's standard practice now to avoid abuses by IT and by IT people is the notion of a code of ethics. Now there's a code of ethics for lawyers, hard to believe, but there's a code of ethics for nurses, for teachers, for lots of professional disciplines where there is great potential harm from their abuse. And that's certainly true of IT as well. And there are codes of ethics that have been evolved, some imposed by companies. There are some industry-wide codes of ethics that should help avoid some of the abuses. It's still human beings, and even when we have codes of ethics for attorneys, that doesn't mean they all practice in an ethical manner. Same is true for IT people, but at least if you have it in writing and you have everybody sign off on it when they join your company, then at least you have the clout of discipline if in fact an infraction is detected. This slide does nothing but raise some really interesting questions. No answers, just things you'll want to think about and maybe we'll get a chance to talk about in class. What uses of IT might be considered improper or harmful to other individuals or society or other parts of the world? There are lots of them, and they're going on all the time. What is the proper business use of the internet or a company's IT resources? And, in particular for yourself, how can you protect yourself from computer crime? There are some fundamental things you can do, and we'll talk about that when we're together. This is an interesting slide about IT careers, sort of depressing in a way. Economic downturns sure have affected IT, have devastated some sectors of IT. Also, technology has eliminated a lot of jobs in IT. A lot of jobs have gone to the Pacific Rim and to places like India, where there's a high-tech workforce where wages are lower. But there will still always be some IT jobs, and a long-term outlook is positive. It says, as long as you're frisky and flexible and willing to stay current. Just scan your eyes around this grid of titles of IT-related jobs, some you might never have thought of. It's just interesting to see that there are many jobs in IT, not just the programmer, systems analyst, operator that we used to think in terms of. In fact, just about every job in industry now has some involvement with IT, even if that's not their primary concern. So where will new jobs in IT come from? Well, rapid growth, but the need to backfill positions when people burn out and move on to other things. Information sharing and client-server environments, a lot of computers turning up in a lot more industries and in a lot more ways. The need for those with problem-solving skills, always strong. The best thing you can do is develop your own problem-solving skills. And falling in hardware, and you might not have thought of this one, falling hardware and software prices dropping dramatically, which will fuel expanded computerization of operations in unforeseen places. It's everywhere, it's everywhere. The IS function, as you can see looking at this list, and you really ought to read this list carefully, because they're all important and they're all true. Some of the kind of interesting ones are like it contributes to morale. We could talk about that one for a while, I guess. At any rate, it's a good list, and it indicates that the information systems function, while it is a functional area of business, it is totally interconnected to all the other aspects of a business in today's IT environment. This slide hints at something we need to try to acquire, and that is systems-level awareness and systems-level thinking. The idea of being able to see in any thing you're discussing Not just the forest, not just the trees, but the forest and the trees. Think of this as one big run-on sentence. What is a system? We want systems level thinking. So what's a system? A system is a set of interrelated components with a clearly defined boundary working together to achieve a common set of objectives by accepting inputs and producing outputs in an organized transformation process. Well, that's what a system is. Doesn't mean that it's just a computer system or any particular system. In any system, you can identify the inputs and the outputs and the processing that takes place on those inputs to produce those outputs. So input is the process of capturing and assembling the elements that enter the system to be processed. Output, transferring the transformed elements into their ultimate destination. Of course, the processing is whatever transformation takes place on that data. Would the things were this simple, but we can abstract them to identifying input, processing, and output. And in fact, we call this our logic cycle of input, process, output. You all heard the word cybernetic, I'm sure. Cybernetics. Besides the usual input, processing, and output, a cybernetic system is a self-monitoring, self-regulating system which adds feedback and control. You can see the difference between feedback and control. Does that not sound like your body, actually? If you think about it, when you're walking, you get feedback that lets you adjust to the proximity to the surface you're about to step on and place your foot and determine whether you're on safe ground or not, and give some feedback to your system as to whether it's safe to shift your weight to the other foot or what you need to do, things like that. So we're pretty good cybernetic systems ourselves. Here's an example of a little feedback system you're probably used to, trying to control the temperature in the room. You have a thermostat, you set it for the temperature that you want, based on the difference between the temperature you want and the temperature that it's currently at. It's going to adjust the voltage, which will, assuming you have a gas furnace, which will control the valve that allows fuel into the furnace, where some of the heat goes into the room and some of the heat gets lost. At the end of which the actual temperature gets fed back. Here's the feedback loop. Back to the thermostat, which determines whether to continue running the furnace or stop. So that's a feedback loop. Lots of examples in your life of a similar thing. Another example would be cruise control in your car. So if we know that a system has input, processing, output, feedback, and control, we can easily abstract a business as a system, where if the management is the control and we see the entities in those boxes which are the input, the processing, and the output, with the information system as the feedback in the middle between those. That's the flow we were talking about. But the most interesting part of this whole document is this whole slide is probably what's written around the edges of that square. All of the external entities which are part of the information flow in a business, the community, competitors, customers, stockholders, labor unions, financial institutions, suppliers, and of course government agencies, all part of the information engine of a business. Can a system be part of another system? Can a system have systems within it? The answer is yes and yes. If a system is one of the components of a larger system, we call it a subsystem. Doesn't mean it's not a system when examined with its own components. But we call the larger system, we might refer to that as the environment in which the subsystem operates. Sometimes you have systems which aren't one within the other, but which may share the same environment and may be connected via a shared boundary or an interface. One system often feeds information into another system. In fact, that's the way business is done. Remember that list back in the beginning of this chapter of the 5 components of an information system? Well, this is a little different view of it, drawn into a pentagon where they have the people resources, the software resources, the hardware resources, the network, of course, the communication which makes it all hang together, And the data resources, the procedures are embedded, the policies and procedures are embedded in some of these other things. When we talk about the resources in an information system, people first, people first, people first. Various kinds of specialists, of course, we are all specialists at our own job, and we're all end users as well. Hardware resources, those are the machines. Media is sometimes not included in the hardware, but it's tangible, and to that end it's hardware, that stuff on which data is recorded, for example, optical discs, things like that. Software resources, of course, the programs and the procedures that make them work. That's part of the information system. But of course, we also have the data resources and the network resources. And by the way, they've picked up a new one here, information resources. And now we're going to have to quibble about the difference between data and information. Data here, product descriptions, customer records, for example, facts. Information, management reports and business documents using text and graphic displays, audio responses and paper forms. Information, you might be able to detect a little bit difference here between data and information, and we'll quibble about it on the next slide. Network resources, of course, everything it takes for components to communicate with each other. All right, what's data and what's information? And we could argue about it all the time, and fact is we often use the terms interchangeably even when we shouldn't. But basically, if we wanted to be strict about it, data, raw facts about physical phenomena or an individual transaction. Information, data's that's been converted, processed, and put in a context for users. That word context is important here. Okay? Now, given all the stuff we know now that we didn't know in the beginning of this chapter, let's expand our notion of what information system activities are from input, process, and output. We're going to expand that list to the following 5 things: input, process, output, storage, and control. Okay, we've talked about feedback and control a little bit. So, an information system, it does all of these things in a very complex, interconnected way. Input, process, output, storage, and control. And this is the end of chapter 1.